Hello everyone, it's April 24th. Alright, today is the first, I think it's the longest I've ever worked. My god, it starts at 10 o'clock. It was the stand-up. 10 to 10:30, okay, that was the stand-up. And then I have half an hour break. And I start from 11 to 12:30, full work, no break. And then 12:30 to 1, I have my lunch break. And then from 1 to 4:30, straight through, no break. And at 4:30 to 5, another meeting. Came back home, and I think from 6, I think from 5:45 all the way to 8 o'clock, another third session. Man, it was brutal. It was absolutely brutal. If it's gonna be like this at the end of every, like before the release, if it's like this, man, it's gonna be a long career. Something needs to be better. I mean, we can't. This is not sustainable. I mean, I'm having a headache right now. All right. Anyway, so what's today? A Fibonacci number. Okay. All right. I'll just do it. Oh man. Oh, yeah. My head hurts. At a certain part inside, it's been zapping me the whole day. You know, the whole day. So I have to say N1. N1 is what? N0 is 0. Okay. T0 is 0. T1 is 1. I think T2 is also. Alright. Okay. If n is equal to 0, oh, okay. Then for I equal to 3, smaller equal to n, I plus plus. We have, we need to move forward, right? Temp T0 plus T1 plus T2. Okay. Then T0 equal to T1, T2 equal to, no, T1 equal to T2, and T2 equal to temp. Right? Oh. Oh man. Oh. Oh. Cannot define twice, right? Yeah. Man, why it hurts so bad, man? Oh. All right, so today it's an easy problem, so let's go head for this one. Okay, so a little bit different ideas. So the previous idea, I don't think it works, so I'm going to change the idea. Yeah, so this one doesn't work. All right, so what my current idea is, we'll get all the cycles out first. You know, we can have the cycle. All right, here's a cycle. So we just start from the first, and then we just go, and then we'll create a dictionary to record the cycles. No, not dictionary. Yeah, so we have cycles. Within it, we just get cycle, and then each element, it's gonna be a tuple of a list of this thing, and then the index start from where we have the cycle. Okay, so we have this, we have this, we have this, we have all of them, right? So as we go, and this is actually because we need to append the front, so it's gonna be a deck, right? So whoever it is, we go, and then until we hit the end, right? Okay, now we get a whole thing. Oh, index. Yep, and then we'll record for every one. So we also have a receiver. We need to know which one belongs. Right, which one this belongs to. Yeah. Do we need to know which one this belongs to, though? We probably don't. We probably don't. We just need to know the length of the cycle. That should be good enough. But how do you know the length of the cycle? Because we go, we push, right? And then we find this. I need to know its index. But then this one, I use it once and I throw it away. Huh. No, it's fine. I'll push it index. Right, and then later on, if I find something, and then boom, it hits, then we simply just merge the two. Right? Merge the two. Then at the end, what we're gonna get is just some, another one, another one. So this is like within this receiver, we have these, and then we just start calculating what's the case steps will lead to. We can try a little bit. Yeah, cycles. Right, and I will also need to know which cycle you belong to. Right, which cycle you belong to. Which cycle you belong to. Cycles. Which cycle? I'll get the -1. Right, which cycle? And then we're gonna say build cycle. Right. Nah, build a cycle. Yes, build a cycle. And then we start from a index. Let's call it index. And we don't return anything this one. We don't return anything. All right, and then what do? We go through every single one, and this one receiver, when the receiver is set to -1 when it's handled. All right, although so every time build cycle, we will go through. Right, so current is this, and then we shall say while receiver index is current cycle and which index, current equal to index, while receiver is large or equal to 0, then we put this into it. So we say current cycle dot append current current equal to receiver current. All right, and then we try the next one. Keep going until we get out. Okay, until the current we get out. So the current we get out is because it's either, so our receiver current larger than 0, and then we do this. Yeah, we need to go next. Next equal to this, receiver current equal to -1, current equal to next. Right. I know we get out. Right, we get out, and we should check. We say if which cycle current. Right, which is cycle current, because I reach this current, and I say if which cycle current is larger equal to 0, that means if it's larger equal to 0, that means we have a cycle for the current already, right? Oh, we have a cycle for the current already. Okay, so this one is already in the cycle. Then we just need to put everything from, yeah, it's already in a cycle. Then cycle stat. So let me be more explicit here. cycles I shall equal to a deck and a cycle length. Oof. Right, so if it's larger than 0, then what we need to do is cycle I 0, right? So we say for C in range. Now we say for I in range I don't like this. Current cycle and we say cycles which cycle current 0 dot prepend append left C. Right, so we go through this, right, or finish, and each time we do it, and then we just say which cycle C shall equal to which cycle current. Okay, that's that. We're done. Else, we don't have a cycle, so we build a cycle, right? We build a cycle. So how do we build a cycle? We will put, oh, yeah, we can just put this one inside, right? Which means this is a deck. Oh, wow, that's not right. All right. Else, we shall say cycles dot append deck, not deck, current cycle, and then the length. Well, the length of the cycle should be len current cycle minus which index current, right? So if it's 0, 1, 2, 3, so length is 4. If I add 1, 4 minus 1 is 3, 1, 2, 3. Yeah, so minus this is the length of the cycle. And that's it. Oh, because it's a deck, right? Shoot. Screw this. That's fine. I just use I range. Right, okay, so that's that. Okay, this is gonna be a list of tuple of deck and int. And then this is going to be a deck of int. I probably should do this one of int as well. Okay. pen left. Sorry, this one. Yeah. Okay, so that's build cycle. So what we're gonna do is I range n. Okay, if receiver I is larger equal to 0, then I say build cycle I. Okay, so after we run this, the cycle should all be built. Okay, now after the cycle is built, then we just need to go through each cycle and then find what we want to find, maximum possible scores. So okay, so next we have to define another function. Alright, okay, so def compute score. Compute max score. And we have a cycle index. Okay, and then we'll return it. So give me a cycle index, I will do that. All right, cycle index, so I can get a cycle. Yeah, cycle index, I think it's easier. So given the cycle index, I'll get a cycle out, I'll get that out. And then what we need to do is we start from the front. And then we're gonna go to case depth. Some sort of sliding window. So we find the first k. All right, it depends on k. If k is smaller, then we just go there and then we sliding window. Right, we sliding window through the whole thing. And then we'll wrap around. Yeah, we'll just keep wrapping around and keep adding, keep adding, keep adding. If k is larger, then we add the whole thing, and then we have, a few more. A few more, and then, yeah, we just need to know the start and end. That's it. We know the start, we know the end, then we just go through. Just do it once, and then we can get everything. And if k is big, which is fine, we will find out how much we need to add the sum of the cycle. Because I know the cycle length, so I can do, actually I can do from back to front, so I can compute the cycle length. Actually, no. Say cycles index. It's not cycle, it's the array and the cycle length. Right. And then we say cycle start index should be len array minus cycle length. Right, 4 minus 3. 4 minus 3 is this. Yeah. Okay, so now I have the cycle start. I have cycle length, I have the array. First is the cycle, first is the length of array, right? So we say if k is I mean, we can still do it. This is the same. It's the same thing. It doesn't really matter. We have the cycle length. We have this, and then we just say k. You know what? K smaller than or smaller equal to. Right? Because it's the additional. We'll do this. So k smaller equal to len array. Then we'll just sum up, right? S shall equal to sum array all the way to k. So k is the length. Yeah, we do that. And then we say low, high will equal to 0 and so k minus 1 is the high, right? K minus 1 is the high. And we need to keep going until low hit the last one, right? Low hit the last, because we're starting from here, right? We end that there, starting from here. So we should say for low, in range this to the end. And the first one, it hits nah, I don't think that's how it goes. So low is equal to 0. Okay, so for high in range, that's not true. That's not true because we want low to go. So for low in range all the way to len array, right? Because low I have to hit every single one, and a high, and I have the S already, right? I have the sum already. So every time I shall say, because I start from here, right? And I compare the sum, then should be the previous one minus this and plus the current. Okay, so it'll be like this. 1 to this. And then this is going to be the rest is equal to 0 because I want to find a maximum, right? And we'll say S equal to rest equal to this. Okay, so now we have here, every time we go from this one, and then what we're gonna do is S or minus equal to array low minus 1, right? Because I remove this, I start from here, and S need to plus equal to array something, so it'll be low plus k minus 1, right? Because we plus k. Right, if we have 3, right, so oh, the k is the total number of passes. So just plus 1, plus 2, plus 3, just plus k, right? Plus k. So load here with plus k, right? And now we need to consider wraparound. So if this is too big, I need to wrap around. But how much wraparound do we do? So what we need to do is low plus k, right, is the index. Okay, low plus k, so it gets out. And then mod yeah, how do we wrap around? We need to compute the relative, right? So low plus k is this position, and this position minus the start. Okay, so this position minus cycle start is the relative position. In the relative position, we can mod, right? In the relative position, we can mod cycle length, right? We can mod cycle length, and then we'll plus cycle start. Okay, so that is the after we cycle back, right? Okay. So s equal to this, then we say rest equal to the maximum, rest in s. Repeat, 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 and then we're done. Okay, so that's when k is smaller. Okay, what if k is larger? Well, if k is larger, then we have to wrap around already. So it depends on how many larger, right? So what we're gonna do is we will compute two things. Okay, we'll compute two things. We'll find that, okay, so the non-repeated part. So sum non-cycle equal to sum array all the way to cycle start plus 1. No, just cycle start, right? So this is the no repeat part, and sum cycle is sum array cycle start towards the end. Okay, so now we have both, right? Now we have both, and then we need to find the s. So the s shall be, k minus cycle length, right? So k minus cycle length. So that's the non-cycle part. So the remaining is a cycle. So we need to do a div mod. So quotient and remainder shall be div mod k minus cycle length and the cycle length, right? That's the div mod. Minus cycle length. Wait, hold a second. That's not true. I want to know. No, it should be k minus cycle length is the non-cycle part. So now we need to go k, right? No. That's not right. So it'd be k minus len array plus cycle length. So minus len array minus cycle length. That's the non-cycle part. So k minus the non-cycle part is the cycle part, and I divide it by cycle part. So we have a quotient and a remainder, right? Quotient and a remainder. So now what we need is to find the s, right? The s. Actually, I think this one we can go even easier than this. So we have a low, so we just need a high, right? So low is here, and then we just need to add that and push the high forward. So basically we can say high shall equal to this thing, right? Hurt. And the low is going to be 0 or 1. Oh, we still need this. Nah, we still need this. This is yeah, we still need this because we still need to calculate. So this here is the same. Okay, here is the same. So we have the quotient. So we have some cycles, right? And then we have the r, the remainder. So s equal to res shall equal to some non-cycle plus some cycle times quotient plus some array with a start from cycle start and with cycle start plus r, right? R remainder is 0, then we don't do anything, right? But if remainder is 1, then we'll add 1. 2, we'll add 2. Okay, so that's the sum at the very beginning. Okay, what's next? So we need to loop around again, right? And in this case, okay, here is the thing. How do you make sure that this is always correct? See, that's what I'm saying, right? That's what I'm saying. What I'm saying is you need to get the high first. So now you just need to do high plus 1. Because here, this one is prone to error. Okay? I think this is prone to error. So what I want you to do is get a high. Right? We get a high. And which points to the current end. Okay? We point to the current end. So high, we start with k minus 1. We point to the current end. Now low is here. Then we do this. Now high need to basically move forward, right? High basically need to move forward by 1. So we can say high shall equal to high plus 1. But then high plus 1, we need to do this. High plus 1, right? And then high plus 1. Then what? High plus 1 minus cycle start, right? High plus 1 minus cycle start. Well, it depends if it's yeah, it depends, right? So high plus equal 1, right? And then if high is outside, right? If high is inside, then it's fine. So if high is larger, if high is equal to, because we go out, right? If high is equal to len array, okay, then high equal to cycle start, right? And then this one will be array high, right? So that's how you loop around. We find the initial high is going to be k minus 1, yes. And then we say now low is going to start from 1. Okay, so s now minus equal to this, perfect. And then high need to plus equal 1. If it's still within, we just use it. If it's outside, then we loop back. Okay, so that's much easier. Here is the same, right? So we have this, we do the div mod, we get this. Perfect. Now all we need to do is to find high. So what is high in this case? Well, the high is going to be cycle start plus r minus 1. This is the high, right? This is the high. And depends on how many times you loop around. So that's current high. And then we do for low in range. Ooh, I think this part we can borrow, right? I think this part we can borrow. So basically what we're saying is we get a high, we don't need this, right? So we get S, we get a result, we get a high, and then low is always going to go through this. S minus equal to this, high plus equal 1. We do this, and then we do this. And at the end, we are going to return res. Okay, so that's the second function. Now what we're going to do is go through this first, right? And then we'll say res equal to 0. And then for I in range length cycles, okay, then we call compute max score I, right? And after we do that, we just say res equal to maximum res, all this, and at the end we return res. Okay, what do you think? Well, what I think is we are going to try, and we can call it cycle index. Argument of type cannot be, wait, what? Array is, ooh, a deck doesn't have it. Damn. That's fine. S equal to 0 for I range k, because it's, ooh, here, hold a second. Because we start from here, we do k, right? If we do 2, so actually it's 3. So it should be, yeah, k is, hold on, 3 pass, 1, 2, 3 pass. So actually it's 4. So the length should be 4. Should be k plus 1, right? Should be k plus 1, because that's the total number of elements, right? If it's 3 passes, we have 4 values. Okay, so if this, and then I include this, s plus equal to array I, and at the end we can say res equal to s. Oh, I don't even need this. We'll just get s. Res, we'll get the res side here. Okay, I'll say res equal to s. And we can say s equal to 0. Don't do this. Okay, so here's the same. Okay. Sum non-cycle equal to 0. So for I range cycle start plus, no, just a cycle start. Okay, just to cycle start. Sum non-this plus equal to array I, right, to cycle start. So we don't need this. And then for j or I in range from cycle start to the end, len array, right? Some cycle is 0. So we say some cycle plus equal to array I. Okay, so we do the sum cycle, this is done. We do this, we'll have one more. Right, one more here. This is sum partial for I in range cycle start all the way to cycle start plus R plus just plus R. Okay, so this high should be K. Right, because it's 1, we point to 1. 2, we should point to 2. This is fine. This is fine. So here, okay, here's k plus 1 larger than, so it should be k plus 1 minus len of this minus this, right? Okay, some partial is from this towards, so if this plus 2, so we went plus 1 plus 2, right? Oh, yeah, so we add to there, and then we say cycle sum partial plus equal to array I, and then this is gonna be sum partial. Okay, S get it, and high is going to be this plus R minus 1. Yeah. Then we get out, get a rest. So low. We'll minus this, high plus equal 1. If we get out, we'll go back here. And we'll plus equal to this because high already moved forward. Then we go this. And then we do this, and then we do this. Okay. Oh. Oh man. Oh, my head hurt. Terrible. Oh, Lord. Okay, so give a shot, see if it works. Key error. Which index? Oh, did I not set which index before? Okay, current cycle, which index? I just want a cycle length. All right, I want to debug a little bit more, and then if it's still not gonna work, then we'll call it a day. Okay, so the first one worked, the second one doesn't work. Okay, we're gonna go with the second one. Okay, so the second one, we start from 0. Actually, we should do the second one. We have 1, 1, 1, 2, 3. All right, so we start from 0. So receiver 0 is large equal to 0. So we build cycle from 0. Okay. So we build cycle from index is 0. And okay, which index of current is 0? Well, receiver, this is large equal to 0. So cycle will add current, which is 0. And which index? 0 has 0. And next will equal to 1. So receiver, this become -1. Okay, so next is 1. Receiver 1 is large equal to 0. So current will append 1. And which index? So 1 has index as 1. And then next is 1 again. Receiver we set to -1. Okay, current is 1. Now we break out. So current is 1. And I say which cycle? 1 large equal to 0. Which cycle? No, 1 is not. So we go here. So cycle is the append. Current cycle, which is this. Line will be this minus which index? Current. Okay, I don't know why this one is wrong. We can do debugging tomorrow. Yeah, let's do debugging tomorrow.